Hello, everyone. If you'll allow me to divert your attention, if briefly, I was going to go and take my evening walk. As you know, sometimes I take my evening walk, but I really decided just to make this video because I was thinking of a few topics, but it's really about a subject that is lamentably neglected in the prevailing pedagogy of our day. And we are talking about the singular and exalted virtue of the approach that we take at City Tutoring to teach mathematics. And we take the set theoretic and abstract approach to mathematical instruction. And even for the youthful and unseasoned intellect of high school students. That's one of the reasons why people ask me all the time. One of the most common questions I get, and people wonder, they say, how is it possible that so many of your students come from the public schools, or they're they, because some of them even come from, I teach, some of the students have troubled backgrounds, and yet they are motivated and they are doing things properly compared to many other places. Why is that? And so I thought about making this video as a prelude to another video coming in a few days about, because there were rivers of tears this morning at City Tutoring when another batch of so-called honors, quote unquote, students from the local high school came, and they got destroyed on our entrance exam. And so I am currently writing up the report, and I will be sharing with you all the results of what they got wrong, as well as the remarks I told them in the auditorium during a very serious chapel hour, telling them to shape up or get eaten alive by the rigors of mathematics. We take this very seriously at City Tutoring. This is not a joke of an academy. And people better start shaping up because they're going to see the consequences of their lack of thought. And it is really a melancholy truth that is corroborated by the chronicles of the rigorous mathematical tradition, that learners are too frequently consigned to the barren expanse of what I shall term the procedural method. Many of you know exactly what I'm talking about. It's a dreary landscape strewn with formulas bereft of meaning, manipulation stripped of reason, and heuristic devices that glimmer like false treasures, and yet they crumble under scrutiny. I call that Betty Crocker mathematics. And in such curricula, calculus is presented, for example, and other subjects, but even the calculus is presented as a conjurer's trick, and algebra as a litany of recipes to be memorized, and probability, assuming you even get that far, as the caprice of dice and cards, devoid of any principled foundation. And yet, mathematics, in its most sacred essence, is not a mere assemblage of clever tricks. It is a grand edifice constructed with the immutable bricks of logic, the mortar of definitions, and the soaring arches of sets, functions, and relations. And herein lies what the resplendent merit of the set theoretic method. From the very first encounter, the student is not merely led to compute or to mimic, they are beckoned to contemplate mathematics as a harmoniously ordered cosmos. And the numbers are no longer, from that point of view, idle symbols to be shuffled or conjured. They are inhabitants of well-defined sets. And yes, we go over that at City Tutoring. We know, my students know what it means. They are each governed by exacting rules. Functions are not whimsical formulas. They are deliberate mappings between domains. They are precise and inviolable. And the relations are no casual correspondences. They are the very scaffolding upon which the cathedral of mathematical thought is erected, and it's sturdy, elegant, and enduring. But I have to confess that these reflections are not purely theoretical. They are really born of memory. because I've been thinking about it recently quite a bit because I happen to be going through my papers, as I mentioned, and I came across the syllabus for my mathematics class at Columbia University when I was an undergraduate. And those were brought me back memories of those exhilarating days um, when I had first encountered, in reality, mathematics in its truest garb. Uh, because Spivak's calculus, some people pronounce it as Spivak, but most of my professors used to pronounce it as Spivak, so that stuck with me. Spivak's calculus was our guide. And to open that volume was not to confront a list of mechanical recipes, but to be ushered into a dialogue with the very architects of analysis. And the thrill of being instructed not in shortcuts, but in principles, not in mnemonic tricks, but in the architecture of sets and proofs. It was a privilege beyond reckoning, and one felt less a student plodding through exercises, and I felt more like a junior participant in an intellectual republic whose citizenship was granted only to those willing to reason with precision. And let me dispel at once a common caricature. These students were not a lot of people have this image of pure math students as some kind of bespectacled, yes, I wear glasses, but I'm saying, uh, sort of bespectacled nerds of the popular imagination, hunched and joyless. And on the contrary, the majority were curious, ambitious in the right sense of the word. I'm not talking about the materialistic sense. I'm saying ambitious in the curious sense, animated. Indeed, many were the best customers at the bars in Morningside Heights, New York, otherwise known as Harlem, by the way. But Columbia used to like to say, oh, it's Morningside Heights. They didn't want to scare some people. But it was proof enough that rigor and revelry are not mortal enemies. And to study mathematics seriously was, in that setting, not a withdrawal from life, but an enlargement of it. Our proofs by day sharpened our conversations by night. And if we occasionally waxed eloquent over a pint about epsilon delta limits, well, it was only because we knew there was real substance beneath our mirth. And truth be told, uh, the soil for this sensibility had been prepared long before university, long before the college. Because in our high school years, so many of us, and you can, if you're a pure mathematician, you can probably relate to this, or if you're a math student currently, how often did we sit amidst conversations that seemed intolerably stupid? Endless chatter about trivialities, opinions, flung about without the faintest regard for consistency or reason. And to a young mind already trained, however imperfectly, in logic and the rigors of abstraction, such talk felt like so much noise. And we would nod, smile, even play along sometimes. I didn't play along all the time, though. I sometimes had to call people out. But inwardly, we felt the cool satisfaction of superiority. I hate to sound like that because I don't. It's not good to promote arrogance, but if you know, you know. And we possess the key to a higher mode of thought, a compass not swayed by whimsy but by reason. It was not arrogance, really. Some people might interpret it that way, but it was really, at least not entirely. It was simply the recognition that while the world wallowed in contradictions, we had begun, however tentatively, to inhabit a realm where definitions reigned, arguments had teeth, and truth could be demonstrated rather than asserted. You have an example in one of the most familiar of objects, the function, right? The function. If you study functions in the dreary procedural paradigm, The instructor usually contents himself with scribbling an example. Say f of x equals x squared plus 3x minus 5. And then you get students, they bid you to evaluate it at sundry values, perhaps sketch its parabola, and then, as swiftly as it came, the concept is abandoned, and the function becomes, in your eyes, a mere machine. Numbers fed in, numbers spat out. A shallow amusement. I was actually, I can't do, I'm not going to name drop in this video, but someone recently sent me the name of an Argentinian mathematician who describes a function as a machine. I'm not going to say he or she. I'm going to say it's, because I can't give it. I don't want to give it away yet. Let's say it's a very well known math professor in the Argentinian world, and I was very disappointed in the person's video on functions. I'm not discounting the person's teaching merits, but I was disappointed. But when you're dealing with the set theoretic conception, a far nobler picture emerges. And now you get the function is not a trick of algebraic substitution, but a mapping between sets, a solemn pact between domain and codomain, and each input precisely one output, each correspondence governed not by whim, but by definition, by the austere majesty of logic and axiom. And here the student begins to perceive that mathematics is not, it's really architecture. I always describe it as a cathedral of thought, whose every arch and column rests on foundations that cannot be shaken. The abstraction may daunt, but it is precisely that elevation which trains the intellect to clarity, to rigor, to discipline. Now, I am well acquainted with the objection. It's murmured always by cautious types and souls, but surely such abstraction is too much, too lofty for youth. And to which I reply, it's nonsense. There is no intellect too tender to be sharpened by exact thought, and to defer rigor until some hazy later stage is really to insult the young by serving them sweetmeats in place of bread. It is to present mathematics as a carnival of entertainments rather than as a republic of reason. And by introducing set theory early on, we, at City Tutoring at least, invite the student into the society of thinkers, and teaching them not merely to calculate, but to discern, to define, to reason without contradiction. And these qualities are more precious than all the mechanical dexterity in the world. You can observe the contrast. You have the graduate of rote computation, and he may grind through 10,000 exercises and yet be struck dumb if asked to prove even the simplest theorem. Many of you watching this video, you know exactly what I am talking about. You are incapable of proving anything. You'd feel lost. You have no idea what to do. That's why I'm making this video. I'm going to give you some advice on that. And the student mistakes repetition for mastery and procedure for understanding. You have no understanding at all. And by contrast, if you are trained, the pupil who is trained in abstraction, even if fewer in number, he may not have as many drills, but he emerges capable of generalization, of invention, of seeing the invisible order that binds mathematical truths together. And that is the difference between the calculator and the mathematician. between proficiency and literacy. You can take, for instance, the profound and yet accessible notion of, if you're a math person, you know what I'm talking about, cardinality. In the standard curriculum, you introduce sequences and series as mere collections of numbers, and there the matter rests lifeless. And yet, in the set theoretic spirit, the student is led to inquire, what does it mean for two sets to be equal in size? How might an infinite set be compared to another infinite set? And thus, the mind is ushered into the realm of, you get into bijections, injections, surjections. If this sounds like a foreign language to you, you're not in a real math class. You're not taking mathematics. You're doing something else. But those are the very instruments by which Cantor himself distinguished between infinities. And such concepts, far from being beyond the grasp of the young, are precisely the sort of intellectual delicacies that awaken wonder, that reveal mathematics as it truly is. It's not a menagerie of formulas, but it's a harmonious edifice built from the simplest and the purest of notions. Now, while we revel in these virtues, let me take a moment to acknowledge a modern companion in the pursuit of understanding. I want to thank today's sponsor of this video, brilliant.org, brilliant.org, because in my own exploration of rigorous abstract reasoning, I have found Brilliant to be a most admirable guide. It does not merely provide answers, nor does it indulge the student with flashy shortcuts or idle intuition. Instead, it structures challenges carefully, guiding learners to confront complexity, discover patterns, and exercise true reasoning. One may think of it as a gentle yet unrelenting tutor, leading the student through sequences of carefully crafted problems in which abstract principles are not only taught but experienced. I have actually seen the work that they do at brilliant.org, and it's quite good compared to so many of the other styles and platforms you see in our schools today. Um, the abstract approach that is taught in our classrooms, at least at City Tutoring, finds a natural ally in platforms that reward thoughtfulness and mastery over the superficial. I've had a lot of City Tutoring students use brilliant.org. So I want to talk a little bit about what they do and introduce you to them. Brilliant's newly updated math courses build your mathematical intuition while making you a better thinker and problem solver. You'll start at the perfect level and work your way up through interactive challenges that bring abstract concepts to life. Courses focus on the most useful, applicable math concepts so you never feel like you are wasting your time. Their science courses help you develop your scientific intuition through visual interactive problem solving that gets you hands on with key concepts. You'll learn to think like an engineer with lessons on electric and digital circuits, gear systems, physical structures, and more. Brilliant's growing collection of programming courses is a great way to build the timeless problem solving skills to thrive in the evolving world of programming. From learning Python to developing an intuition for computer logic, you'll get hands on experience with real programs and learn to think like a programmer. And so, to learn for free on Brilliant, you can go to brilliant.org slash forward slash city tutoring math. Again, brilliant.org slash city tutoring math. Scan the QR code on screen, or you can click on the link in the description. Brilliant also gives our viewers 20% off on an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. And so, returning to our philosophical defense, abstraction is not merely a pedagogical preference. It is a moral imperative for the mathematician's mind. Consider the humble notion of if you think of numbers themselves. If you are in a procedural curriculum, the natural numbers, if you even get taught the term, they are often taught as if by rote. One, two, three, and then arithmetic operations follow. But when treated abstractly, the natural numbers, as I share with my classes, are a set defined by axioms. You have a chain of reasoning that explains why addition works, why induction is valid, and why mathematics is coherent. One may argue that abstraction intimidates. I've heard that all the time. But I assert that it empowers. It liberates the student from the shackles of mere calculation, offering instead the grandeur of mathematical vision. Like I said, I have taught, I had this just this morning, I had troubled students. When I say troubled, I mean um, some of the students have been in jail even. And yet they understand perfectly when we explain to them what the axioms are. We are in keeping with that tradition. Our students are by far more at city tutoring, and I don't mean to sound like that, but if you talk to them, you'll notice they are by far more cultured than the average, than the public school students. We teach them things like what are the Arabic numerals, the Roman numerals, the binary system, the decimal system, the Dewey system, all the number systems that exist. And moreover, abstraction also fosters transferability. A student who has learned to reason in terms of sets, functions, and relations finds themselves they are able to tackle probability easily, algebra, calculus, and beyond without having to memorize new rules for each domain. Some of you young people are struggling right now. You have no idea because you don't have the foundations. And the abstractions are universal. The reasoning is transportable. Compare this with with what I call the procedural curriculum, in which each topic is siloed, each formula isolated, each new subject requiring a fresh set of tricks. But abstraction, I submit to you, is economy of intellect. It is efficiency in thought and a foundation for true creativity. Let's consider another as an illustration the matter of logic itself. High school students often encounter conditional statements or proofs by contradiction in a very, if at all, if you are even encountering it, you encounter it in a very cursory manner. But when you have a set theoretic curriculum, logic is embedded at every turn. A student learns that a statement is not merely true or false, but resides in the architecture of implication, equivalence, and necessity. One may even introduce the beauty of quantifiers for all, and there exists. If you watch my Pure Mathematics channel, you'll see it. And I will link it in the description as well. Not as ornaments, but as they are essential instruments of rigorous reasoning. And you cultivate a precision of language, the same precision that underlies the greatest theorems in mathematics. And when you defend abstraction, you must also contrast it with the prevailing emphasis on intuition or shortcuts. Consider the current trend to present calculus, probability, or algebra. Most of you do it like computational exercises, and they may dazzle you momentarily, but they risk producing minds skilled maybe in tricks, but unarmed for proof. And the set theoretic approach teaches you that mathematics is a system of interlocking truths, and that comprehension arises from careful engagement with definitions and theorems. And to teach otherwise is to offer the students a gilded veneer of understanding rather than the substance of reason. And so we have to keep insisting on these broader points. Allow me to restate the central argument here. The set theoretic and abstract approach is not merely suitable for high school students. It is a profoundly enriching, it's rigor building, and it is an intellectually liberating path. It prepares young minds not just to perform calculations, but to reason, to generalize, and to innovate. It replaces the mindless rote memorization with structured thought. You need to have structured thought, intuition, but not the intuition that they teach today, which is all your feelings, but discipline, insight, and fleeting tricks with enduring understanding. In our schools, we have to teach the students to see the forest of mathematics, not merely the trees of arithmetic where everything is disjointed. We have to cultivate a generation capable of appreciating both beauty and rigor. And let us support the instruction with resources. We need resources. I'm going to share that with you now because I know a lot of you asked me about that. It could be textbooks, platforms, or guided challenges that reward the effort, the mastery, and intellectual honesty. And so, if you really seek to nurture a true mathematical mind, you have to remember that abstraction is not fearsome, it is freedom. It is not obscure, it is clarity. And it is through abstraction that mathematics reveals its true grandeur, even to the youngest, most earnest students. And so we have to teach with rigor, with vision, and defend abstraction, because in it lies the essence of mathematics itself. But I am going to share with you some recommendations because I know you young people ask me all the time, but what can I do? I'm trapped. Well, let me share some recommendations with you. Now, one of the most common questions I get, what can I do? I'm in a bad school district. I have no preparation. Okay, well, fair enough. To truly cultivate a high school student, if you are in high school specifically, but even if you are in college and you never had this foundation, if you want to be capable of thriving in the set theoretic and abstract paradigm, you have to begin first with texts that prioritize clarity, structure, and logical development over mere calculation. I have already shared with you the Dolciani, whatever you want to call it. I call it Dolciani, though, unless I was saying something in Italian. Um, I've already promoted her math books, right? But I know for a fact that you don't always have access to them. So I am aware of that. And I am sorry about that. There's nothing I can do about that. But if you want something similar that is very accessible today, and it's not bad, I have to say, it's not bad, even though it's Cengage, but um, one book I recommend is Epp's Discrete Mathematics. You can get that. You actually they have a free copy, I think, online. It's called Epp's Discrete Mathematics with applications. I'm sorry about that. It does have applications, which is not always, that's not for pure mathematicians, but it does a very good job of explaining to you mathematical thought. I have to admit that. You can also check out Rosen's. It's called Rosen's. The author is Rosen. Discrete Mathematics and its applications, and you could that really provides an excellent introduction. If I recall correctly, the title I think it was Rosen's, but you can correct me if I'm wrong. I know Epp's Discrete Mathematics a lot more. And that really provides an excellent introduction to sets, logic, functions, relations, all of which form the backbone of rigorous mathematical reasoning. And those texts encourage students to prove, to construct, and to reason abstractly from the very beginning. All schools should have that, laying the groundwork for all subsequent study. If you want to complement it, if you're very motivated, you do have a book called How to Prove It by Velleman. And it's okay. I would say that uh, you have to be very motivated, though. So make sure, check out some other books before you do, like the one I mentioned before. You might, even though Velleman is pretty accessible, but it does guide students in the art of proof writing. If you want to pursue mathematics further, it will teach you things like deduction, contrapositive reasoning, and careful manipulation of quantifiers. So Epps books does that too. And those tools are indispensable to any student aspiring to a deep understanding of mathematics. So if this video was helpful to you, please, I ask you to please continue to subscribe to the channel so that we can continue our mission of promoting rigor and honesty and truth and quality in our mathematical instruction, because this country, as you know, the United States of America, is a disaster with mathematics. So thank you all, and I'm always here for you. Please look out later on. I'm going to try and post. I'm finishing up the report on the disaster this morning, the bloodbath at City Tutoring with the results, and I'm going to be sharing the exam with you, and you're going to see the mistakes that students made. Um, and you won't be. Some of you won't be surprised, but some of you are probably making the same mistakes because you do not have a proper mathematics education. Thank you all, as always. May you stay safe, healthy, and loyal to the truth. And one more thing, loyal to pure mathematics.